Hi guys, Mr. Jonah here. In this video there is mess on a table, but mess on a bench has nothing to do with this video at the moment because I'm recording this intro after I actually already did everything and the client received the product. But anyway, in this video you will see a little board that I made for that currency detector. The board is made using a permanent marker, not a toner transfer. I had some footage of me babbling about that board, but I was handling the camera just like this in my hands, and yeah, the freaking rubber bumper kinda silicone stuff, a protective case on the phone squeaked so much that I rendered that footage useless. But long story short, I made that board using just permanent marker and then etched it as usual. So without further ado, let's go into the video. Alrighty, looky what I've got here. I've got a finished board, which doesn't look half bad considering the effort I used while making it. Doesn't look as bad anyway. You can see where the mains are gonna come in and the output to the LEDs, positive, negative. And when you thin the tracks nicely, you don't see that pitting at all. It's nice and shiny. Awesome. Yes, I changed the cap to 220 nanofarads, but next I'm gonna actually show you that using 150 nanofarads, which I calculated in another video, will result in exactly the same current that I actually used in that calculation. Because why I chose to use this capacitor, I wanted to get more brightness of it, that's all. It's not like my calculation didn't work. I just picked a bit too low of a value. I just needed more current, not 10 milliamps, but 14, which what this will draw is gonna be just fine. I'm gonna mount it somewhere there, but right now I'm gonna go and show you another circuit which will draw 10 milliamps. So that's how the LED module looks like. Just bunch of LEDs zigzagging, you can see there. Yeah, you can see how badly this thing is chipped. I made a huge mistake that I went and I drilled this hole straight with a 4.8mm bit. It came out pretty clean, as you can see, but all the other ones I chose to pre-drill with a 3mm and enlarge it. That was a huge mistake, and it wouldn't be such a big problem if I would have had another drill bit which is not HSS, intended to drill hard materials like steel and stuff like that. That's not the right bit. It is just too aggressive. It goes into the thing way too fast. I was a bit scared that I may snap the freaking thing. But anyway, here you can see the meter. Here you can see the 150 nanofarad capacitor we calculated previously. Stupid glare. Oh, come on! There we go. 330 ohm, 22 microfarad. I'm gonna plug it in. You will see that I'm measuring the current through the LEDs. And here we go, 8.5 something milliamps. But remember, I used 240 volts in my calculation, and right now, let me hook it up. And right now, We have 220 volts there, thus 8.5 milliamps and not 10. Perfectly fine if you ask me. LEDs are nice. They're not that bright, that's why I chose to use. And the camera doesn't see any flicker. 22 microfarads there, plenty enough. Yes, if one of the LEDs will go open, that capacitor, which is rated 63 volts, will see something like 320 volts and will likely to blow up, but whatever. I'm guilty of that myself, but it's gonna be alright. Where is it rating? Ah, there we go. Probably can see it. 22 microfarads, 63 volts. There we go. Alright, now let me hook. Alright, let me hook this to this, and you will see that we're gonna have a little bit more current and thus brightness. Alright, the scene is connected. As you can see, mains are those two, brown, blue, and the positive output goes through the meter, so you can see the current. And first of all, plug it in, you can see that it lights up, and we have 12.8 milliamps. Awesome. Now the LEDs are a little bit more bright than they were, so I can... oh yeah. That's not preferred way to do it, because if this lead comes loose, that capacitor will see 400 volts, so let me hook it up very nicely. That I'm gonna show you that there is some stuff on the money that glows if you shine this light on it, and I'm gonna wrap it up there. So that's the thing semi-assembled, wire soldered to the LED panel, if you will. I hot snotted them in place, so the solder joint is covered, and it's a nice strain relief, it ain't gonna break off. You can see the board is fixed by the best way there is. You can actually see, since the board is very thin, you can see the splotch of a hot glue underneath it. And then I'm gonna just put it back together and you will see that it works. Actually, I'm gonna go and turn it on. I added an infusible link there. It's that device in a heat shrink there, it's a fusible resistor. Okay. Boom. No flicker whatsoever. Let me cobble it together so it's gonna be noise. And see, unplugged it, absolutely nothing. Because there is that 1 meg resistor which you can see near the capacitor. Focus! There. Alright, let me put it back together. And right there you can see a piece of plastic bag that I hot glued in place. Hot glue! It's the best way there is. Hot glued in place to block that grill. The bag doesn't look all that great from this side, but it doesn't have to be. On the other side it is black. So, as you can see, it looks quite nice. Just blocked off so no dust can get in. Because as you saw in the previous video, there was some dust. I had actually to use a brush before hot gluing the stuff in place, because if you hot glue onto the dusty surface, it ain't gonna hold, of course, because the hot glue will bite into the dust. Hot glue will bite the dust. Funny? Maybe for an like me. Alright. Prepare your surfaces before gluing. Okay, the thing is back together. It's plugged into the voltmeter. You can see a voltmeter here. It's turned on. And we see that's times 10 range, so it's 0.78 watts. Quite a lot, if you ask me. So, and we know the current is about 13 volts. Nice one, Johnny, nice one. It's about 13 milliamps, so we go 0.75 watts over 13 milliamps, 57 volts across that, across those LEDs. And that is, the capacitor is rated 63, so we are fine. Nah, it would have been better to put a 100-volt capacitor there, but I didn't have one on hand, so it will be fine. And of course, there is some, you can see anything there, but if I'm gonna whack it in there, you see a stripe. So obviously it works, does it not? Not so fast though, I talked a bit too fast. The value what you got is oh, it's not this one. What we got is 0.75 watts over our current. We've got 58 volts, but that is 58 volts here in DC. We got 1 volt here, we got 4.3 volts here, because now it's 13 milliamps flowing through this. So as a result of all that, we now got 52.7 volts across the capacitor and thus across the LEDs. So that equals to about 3.5 volts per LED, which is a bit too much if you ask me, but oh well. The current is not excessive, 13 milliamps, they're rated 20. You can use them at 20, they will not burn out, but that may shorten their life expectancy, so 13 milliamps is pretty damn good. A good compromise between brightness and lifetime expectancy. Now, thanks for watching, see ya!